Should we jump into the technical stuff? We've got about 20 minutes, and often I'll take 4 hours to cover the technical stuff. So I'll just give you a very thin slice, highlight of the APIs, and show you some examples and some of the browser support and a couple of tools that you could use. And then I'll be around most of the rest of the day, so I can answer any other technical questions, maybe around lunchtime or something like that. So I work with various different teams within Microsoft. I'm a geospatial technology specialist. I do work with the SQL team and with the data market team. In fact, I'll show you a demo where we're pulling data market tiles and weather station data from data market directly and overlaying it on top of Bing Maps. And I also work with other teams in terms of building, demos and overlaying data. What I wanted to just quickly show you is one demo that I put together, which was using volcanology data, which is very relevant nowadays. It actually is a feed or some data sets that the Smithsonian has, but I think for some of you in this audience, it might be relevant data sets in which we're taking plates, tectonic plates, craters, volcanoes, earthquakes, and we're overlaying them on top of Bing Maps. It's very interactive. You can see this is the direction, the plate motion. You can overlay tectonic plates and craters and volcanoes, and hopefully my network connection is good and it will start loading. There we go. So the data just kind of streams in and overlays on the map, and using different techniques, and this is specifically using a rasterization technique where we're taking all of that rich vector data and we're just tiling it so that we can display it easily on top of the map. So you can see, here's all the volcanoes and the plates, and I can zoom and pan around, and I can switch to individual vectors at a certain zoom level. So I could say at zoom level 6, I want to, my mouse just, at zoom level 6, I want to switch to vectors and start showing, individual points. And so you can kind of see that where it was tiles originally and now it's individual vectors. So that's an example of overlaying data as Peter was describing. Bing Maps is a canvas in which you can pull in many different data sets and overlay it on top of the map. And that was a demo that literally we put together in probably 2 or 3 days of work, starting with Esri shape files, loading them into SQL Spatial, and Ed in the next session will talk about the spatial features in SQL Server, and then using Bing Maps as the canvas for displaying that data. So let me jump into the APIs in the short time that we have. So Bing Maps has 2 web controls, and by web controls we mean this is code that runs in the browser and makes asynchronous requests to Bing Maps to get the base layers, and then obviously you would make asynchronous requests to the geocoder or routing engine to geocode or provide a route or do other things. So we have an Ajax control and a Silverlight control. Either are very good. We've made huge strides in Ajax. I tend to think that if it's a desktop app for internal users only, Silverlight for me makes more sense because you'll get higher numbers of rich or complex features that you can display, like polygons and polylines. So if your app, you want to show a lot of polygons like counties or zip code polygons or other things, Silverlight tends to be a little better for that. If you want to allow your application to be accessible to external people, consumers, obviously Ajax and the support for HTML5 is a good way to go, including if you want to provide mobile applications, those sorts of things. There's 2 web service APIs, a SOAP and a REST web service, and these provide static-based maps. So if you wanted to deliver a static map maybe in a report that shows here is where the incident occurred and you want people to print it out, the REST or the SOAP APIs are good to do that. You can also use the REST APIs for geocoding and routing, and I'll show you some examples of that as well. There is also Photosynth. Photosynth isn't really a true API. It's just something that you can iframe into applications, but as we talked about with the Q&A, that's where you can take a collection of photos, anywhere from 2 to 2,000 photos at any resolution from any camera. You can use Photosynth and synth the photos together into a panorama or into a point cloud in which these photos are represented in 3 dimensions, and then you can allow users to navigate around. So imagine an incident occurs, an environmental incident, where someone takes a whole heap of photos, and and it could be even the earthquake and tsunami types of things in Japan, or any environmental issue where people take photos. You could join them together, and allow people to interact and explore that area and understand what's happening. And so as researchers, you could look at what other people are contributing, where it exists. So it basically takes a photo and overlays it on top of other photos. And you could imagine scenarios. There's actually map apps up on Bing.com in which you can take your own photo from Flickr, for instance, and you can overlay it on where is that photo on a street view. So you could say, okay, this photo was taken from a user that was reporting maybe a dumping of some hazard material. They took a photo of where it was done, and you could automatically match that to the Bing Maps imagery and determine where on the Earth that occurred and do those sorts of things. And then there's map apps. And map apps are really consumer mapping applications that you can host up on bing.com/maps. They are primarily Silverlight today, but there's work being done to make them Ajax 7 as well. But that's where you could mash up data and expose it. And that's more about driving consumer awareness, where you want people to see your data and you want to drive traffic from Bing. So I'm going to focus more on Ajax 7 because it is new and because for a lot of scenarios it is very compelling. It's a JavaScript library. It has the built-in maps and imagery and bird's eye and synth view that Peter talked about. We've made huge strides in the actual JavaScript library download. So with version 6.3, it was close to 300K. That initial control would have to be downloaded to the user's browser cache before your JavaScript application could run. Now it's about 70K, so it's a huge reduction in terms of that initial load time. It supports HTML5 and HTML4 browsers, and again, there is a list of supported browsers to this gentleman's question earlier that you can check out those browsers, and mobile support for iPhones, Droids, Blackberries. And again, that's good where you want to support consumer scenarios. It also supports gestures on iPhones, so pinching the map and panning with your fingers, those things are all supported. And I think that's really compelling because you don't want to necessarily have to, if you're just trying to build consumer awareness, build an iPhone app and a Droid app and a desktop app. And you don't want to have to create multiple code bases. You can do it all with the Ajax 7 control. This is the download size, as I mentioned. So significant reduction. And I just want to talk about the advancements in performance. And this is partly related to HTML5, but it's partly also related to the fact that we've completely rebuilt the Ajax control from the ground up to make it optimized for loading large numbers of points. And there's actually some blogs online that compare these stats with Google Maps as well, if you're interested. Obviously, I'm not going to highlight that heavily today, but you can see with version 6.3 and version 7, that's what we're comparing. When you're looking at lower numbers of individual points, they're pretty comparable. When you get 100, the performance of loading is, 10, 20 milliseconds. It's pretty low. When you get above about 500 points, then it becomes a little bit more apparent. Above 1,000, Bing Ajax 7 is significantly better. And this is saying it takes about half a second to load 1,000 points in Firefox 3.5. When you look at IE8, you can see there's huge performance differences there. IE9 is a little bit better. Chrome 5, you can look. Here is the scale, the time in milliseconds to load points. So this is 2 seconds, 3 seconds. Chrome does a really good job of interpreting JavaScript code, and you can see that the slowest time for 1,000 points is only 140 milliseconds. So again, you can take advantage of some of those things, and that's partly because of the HTML5 and hardware acceleration features. So as of last month, we released a number of additional things like improved events. So if you've been working with Ajax 7, I just want to touch on these because these are some new features. Improved event handling, as well as other events like tile download complete, so you can actually, within your code, capture the event when all the base tiles download, and then maybe that would trigger displaying of your data. We also have built-in features for info boxes now, and that's where you can display more data about a location. Previously with Ajax 7, you had to put a div on top of the map and orient that div. Now you can just use the native info box features, which are a little bit more polished in terms of the UI. So let me just quickly show you a couple of demos. I'm not going to spend too much time on the code because we're running short and I don't want to eat into Ed's SQL spatial stuff, because I'm sure many of you are interested in that as well. So just an initial sort of map load. It's just a matter of referencing the Bing Maps Ajax control in your JavaScript. You have to have a Bing Maps key, which you can see we've specified here. To get a Bing Maps key, you go up to bingmapsportal.com, you log in with a live ID, you create a key. For research purposes and development purposes and other things, those keys are free. If you're planning to do a commercial application, even mobile apps are free as well. If you're doing a commercial application like a Starbucks.com, then those customers will license Bing Maps and get a license key. But you can certainly sign up for keys, and you can see traffic and how many sessions are being used and those sorts of things. And then from within the code, all we really need is a div tag or a div that has the map with the dimensions of the height and width specified. And then when the page loads, we call this create map function. We pass in the map options, which the only option that is mandatory is the key. You can also specify the default map mode, the zoom level, the center point, style, a lot of different factors. And I'd encourage you to look at the documentation. And then we create an instance of the Bing Maps control and bind it to the div tag. And that's what gets displayed on the map. So if I look at this one, just running it locally, it's going to give you a world view because I haven't specified anything. So if you just want to show the world, you don't pass any real parameters in. And you'll notice that we get the panning, the zooming, double-click to zoom. You may have not seen this, but if you hit the shift key and drag, you get the zoom box functionality. So that's kind of nice for zooming around. You'll notice that the default controls are the plus and minus, and you also have the zoom to bar, so you can kind of zoom to different zoom levels, or you can jump to different zoom levels. You can also switch on the different imagery modes. So by default, it's road, but you can also do automatic, which will automatically select. You see it switch back to aerial. It's saying at country level. Aerial is kind of useful because you can see terrain and vegetation and other information at that level. But when I zoom into a country, then it's more interesting to actually show, start showing data and overlaying some of the labels. And then when you zoom right all the way in, you'll actually get this bird's eye mode, which is the imagery. And if I zoom in here, for instance, you'll notice that it uses tilt, and that's one of the options, show angled view. And it'll start showing these synth views that Peter was talking about. So that's a synth view. It looks like a real aerial image, and it actually is a 2D image, 2D aerial image, but it's tilted, and these building models have been added, so it looks like a 3D mode. It looks like a bird's eye image, and then when you zoom in, you see it reprojects slightly there. It slightly changed the angle, and this is the individual photos. So hopefully that makes sense. And then obviously to load points on the map, you can just specify a push pin object. There's also parameters associated with that, but you really just need to specify the location. You can obviously choose the type of icon and the color of the icon. You can even use your own PNG, and then you just push that entity to the map as a child of the map, and it will display. And that's basically what this demo does, is just display an icon on the map. Let me just push forward because we've got 8 minutes to go, and I want to get through the key points. I also do have a data market demo. Let me just quickly show you one screen of that. So this is using parcel tiles from data market. So it's using the OData and or JSON support that where is it? It's hiding. It's not loading for some reason. There we go. So you can see it's actually now, based on where I'm looking, it's loading these green tiles, which are land parcel tiles. So this is coming from Data Market. This could also come from ArcGIS Server or any platform that supports the tiling system that Bing Maps uses, which is a quad key, quad tree based system. And so that's an example of overlaying tiles from Data Market. So as we talked about, the web services and the REST service allows you to get static maps and imagery, geocode, find businesses. So if you want to find points of interest, you can use the APIs, do routing. A lot of times it's used for mobile apps, kind of backward compatible, or server-side processing, and you can see an example here. This is an example REST geocode call. We're outputting in XML, but in a JavaScript app, you would just change this parameter here to JSON, and you'd get back the data in JSON format. We're basically passing in an address in an unstructured way, which is this one Microsoft way. You could also do it structured. You could pass in individual directory paths as the elements of the address, but we're just passing in any address. And if I just enter another one here, you'll notice that we get a result back. All of the requests except multi-stop routing requests will always respond, and there's a service level agreement that enterprise customers can take advantage of in under a second. So sub-second response on all of these requests. You can see it gives me the fully formatted address. I didn't put a zip code in. It gives me the 9-digit zip. So it does some address validation and returns you the full address. You get the lat long. You get a bounding box that represents the best view. So if you want to set the map to view that point in the center, then that's the bounding box that would best display that. And then you'll notice that we get back entity type. So this is actually matched to the address. If I mistakenly typed an extra digit, for instance, if I put that, you'll notice that it actually gives me multiple matches, but matches to the roadblock. So this entity type is very important, and also there's a confidence score as well down here. So it's saying that it's confident to a medium level that it's, a roadblock. But if you look at the previous example, there's a high confidence that this is an address match. And this is actually a parcel geocode match. So it's the centroid of the parcel is typically what gets returned, especially in the US. So let me just keep flowing. I want to show you one other demo. So how do you put all this together? You saw that volcanology example. If you want to build an app that actually shows rich data, whether you have that data in existing GIS formats, maybe in shapefiles or it's in ArcGIS server, well, Microsoft has a number of products that can come to the table here, and Ed's going to talk about SQL Spatial in just a few minutes. But what we created is an open source project called Data Connector, which allows you to basically load all your data into SQL Spatial. You may have it in there already. You could take shapefiles and load it into SQL Spatial. You can take any data set loaded in. We got some publicly available data sets from Natural Earth Data as well as the Census Bureau, countries, world, states and provinces, US counties, faults and earthquakes. And some of those you saw in the other example. The only real relevant thing about these sample data sets is, one, they're free and available online, so there's no licensing restrictions in terms of making them available as a demo. And the other thing is the first three represent polygons, multi-polygon data types. Faults are obviously polylines, and then earthquakes are individual points. And so Data Connector is really all of the code that you need to do to build that rich application, where we've got Ajax and the Bing Maps Ajax control on the client side. We have a data access layer that happens to be an MVC website, but it has the tile controller and GeoJSON conversion elements and all of those pieces, and it allows the data. And in now my last 3 minutes, let me just show you a quick demo of that. This is a running demo, but if you go up actually to ajaxmapdataconnector.codeplex.com, this is where you can actually, see all the details, documentation, download both the sample data as well as the source solution. And let me just run it for you now, which is up on this site. There's three main sort of techniques that you want to consider for web mapping, and this is really Bing Maps independent. One is showing data as vectors only, or the individual features that come from the database or whatever data source. displaying them on the map. And in this case, we're using GeoJSON, which is a standard, to take that data from the server side, from that data access layer, to the client and display it. And obviously, JSON is a good format for that because it's very JavaScript friendly. So in this case, you can see we have all our data sets. We have the earthquakes, the counties. You can see we have query filters. So what I'm going to do is just zoom in a little bit over here and say I want to do a proximity search. Let's do it within 48 kilometers of the Los Angeles area. Hit query. Takes a little bit of time to just get that initial data, but what this has basically done is created a overlay on top of the map. We have 3 counties that intersect, and proximity, by proximity we're saying point buffer, the radius around an individual point, and you can see all the earthquakes and counties that intersect with that. You can also do that as an area of interest. The only reason I really focus on Southern California is because there's obviously some good data when we're talking about the sample data that we have. So this is doing a polygon intersect query. So the data here, my polygon is being sent back to SQL Server. That query is being executed. This one will execute against the database, and the points are being returned and displayed on the map. For some reason, there we go. So this is give me all the data that intersects with the polygon. You could do contains, but this is where this line intersects with all of these data sets. Again, that's showing vector data on the map, and it works great for doing ad hoc queries and showing data on a local level. Doesn't do so well if I was to zoom out and say, give me all the vector data for the whole US. Would basically bring the application to a standstill because you don't want to show more than probably a couple thousand points, vector points on an Ajax map, or you're going to start to see performance issues. Tiling is the way to handle larger quantities of data. And so if I turn on those counties and earthquakes again, it'll pull those in as tiles. And you can kind of see them streaming in as individual tiles, and it'll fill out. And the great thing about using that tiling approach is it's getting the data and asynchronously retrieving it so that the user's not having to wait for the whole map to render. They're not having to wait for each individual layer to render. Those layers come back as the user selects it. You can also do thematic types of scenarios. This is just showing increasing area size of counties. Obviously, if it was an environmental scenario, maybe you could show the number of oil spills per county and do a thematic map. And again, there's no GIS system here. This is just SQL, .NET for some of the data access, but you could certainly do it in any technology, and then Ajax and the Bing Maps Ajax control on the client. And then the last piece is you can combine these things together so that if I had states and counties, or earthquakes in counties like we were looking at before, you could automatically switch from tiles to vectors as the user zooms in. And we looked at this briefly before, but here we're going to say when we get to zoom level 7, we're going to switch from vectors or from tiles to vectors. So if I zoom in again, we're currently at zoom level, yep, there we go. And now it'll go and grab all that data and display it on the map. And as I pan around now, it'll requery. It's querying based on the bounding box now and displaying it on top of the map. That's quite a large amount of data that's being displayed. So hopefully that was a good sort of intro to Bing Maps and what you can do in terms of building solutions. And I think Ed's up next in terms of talking about how some of this stuff can be stored in SQL Spatial. Data Connector is a great way to actually display it on top of Bing Maps once you have it in SQL Spatial. Thank you.
Thank you very much.